So I think we need to get started in order to finish at a reasonable time. And I would like to welcome everyone to this session dedicated to new mobility services and future data management needs. My name is Andrea De Candido. I work for the European Commission in the Future Mobility, Urban and Mobility Systems Unit, where I am responsible for CCAM. And I will be moderating the first part of this session. I will be then followed in terms of moderation, and I'm very pleased to share this burden with Margriet van Schijndel. Sorry for how I pronounce that. Schijndel. Is that correct? That's better already. Schijndel. Okay. And Margriet is Program Director for Smart Mobility at the Eindhoven University of Technology, and she is also part of the CCAM executive group, where she is the cluster leader for key enabling technologies. And during this session, we will be presenting 4 projects. The projects are Avenue, Award, MobiDataLab, and nuMIDAS. And the session will be divided like the previous one. In the first part, 1 hour, when we will have the presentation of the 4 projects, and then another hour dedicated to questions and answers. One announcement, administrative announcement before we start. I understand that a mobile phone was found in this room at the end of the previous session. So if any one of you have lost his or her phone, you can now find it at the registration desk upstairs. Having said that, just to give you a frame a bit the session that is just starting now, we have, let's say, 2 parts of this. In the first part, we will have projects that are directly presenting solutions for automated mobility. And I'm very pleased of the 2 projects, Avenue and Award, that are part of this session, because they demonstrate something that is very important for the Commission. That is, we are not only, when we're speaking about automated road transportation, we're not only speaking about replacing today's individually owned and driven cars with futurely individually owned automated cars. This is not the purpose that we have at the European Commission, where what we're looking for is to introduce new mobility services, a new concept of mobility in our society. And as such, we will be seeing 2 projects. One avenue that is dedicated to new mobility systems in an urban environment, and looking at how mobility, what kind of new mobility services can be made possible thanks to automation. And then we have another project that is looking into how automation will be impacting and allows a different concept for logistic services, which is also another dimension that maybe is not immediately the first dimension that is thought about by the general public at large when we speak about automated mobility, but it's equally important. Transportation of freight and logistic operations is something where automation can have a very significant impact, and we will be hearing about that. And of course, this transformation, because we're speaking about a transition towards automation, is something that is a digital transition, first of all, which means that it is a data-enabled transition. And the other 2 projects that we will be hearing about, MobiDataLab and nuMIDAS, even if they're not looking exclusively at automation of transportation, they are looking at data in general. And all this generation of new data that will be happening, also thanks to the automation of transportation, needs to be managed, needs to be processed somehow. So on one side, we have new tools will need to be made available in order to process all this data that is available and to optimize the way mobility is made available as a service to individual citizens. And at the same time, in addition to this, all this data that is available is an opportunity. It's an opportunity to understand better the different models of the future mobility systems, for example, in an urban environment, and to plan for the introduction of new mobility services. And thanks to the data, thanks to the algorithms that are being developed, this can become a very powerful planning tool in order to see how introducing, for example, new services, the overall mobility ecosystem can change, and therefore identifying which is the optimal service to be introduced. As such, I will not steal any more of your time. I hope that, unfortunately, I must tell you that there is no cocktail waiting for you at the end of this session. That would have been a very good motivational factor to push people to stay until the very last minute. But I hope that the presentations and what you will be hearing is going to be interesting enough for you to stay until the end. And of course, I would like to also remind you all that this is a session mainly dedicated to you in the audience. It's not for us here on stage. So please feel free to ask questions at the end during the Q&A session. This is really why we're here, why you are all here, in order to understand better what is coming out of the different projects that have been funded and how this can impact on future developments in this domain. Having said that, I think I will stop it here, and I will call on stage Dimitri. So Dimitri Constantas is professor at the Geneva School of Economics and Management of the University of Geneva. He is director of the Information Science Institute, and he has been active in research in various areas for a very long time now. He has more than 150 publications in different conferences, journals, and so on. And he has been participating in numerous European-funded projects. Dimitri, the floor is yours.
Thank you. Avenue. A project that is to design the future public transportation. What we have done. So let me see how this is working. Clear? Good. Now, just some data to know what it's all about. That was a 4.5-year project with 20 partners. It was completed in October, last October, with success. We had 4 primary sites and 2 replicator sites that they were integrated. A budget of 15 million, thanks to the European Commission. That was really nice. And this project also collaborated with numerous other projects to import data, import information, methodologies, etc. So it's not just one project, we just collaborated. We needed all the collaborations. Now, the project is completed. Out of that, we learned many, many things. Some of the things are well known to everybody. We didn't say anything new, but it just validated. Some other things were new. So first of all, legal. You all know the legal and regulatory framework, well, it is not there yet. It is fragmented in the European Union. There are no real, oops. Point is, I cannot see over there. I have to look on the other side. Again, my glasses, yes. It becomes a standard. The previous, they had the problem of glasses. Me too have the same problem. So there is an obligation, yes, obligation to have fixed lines. The public transportation has been dominated since 150 years, fixed lines, fixed bus stops, fixed timetables. That is something the operators, they know very well how to do it. When you say change of paradigm, no bus stops, no fixed lines, no timetable, this is something that is beyond what they are doing now. And if we add that there will be no driver as well, well, everything stops there. It's very difficult to understand this paradigm shift. And legally, public transportation with no bus stops cannot exist. All the laws in the European Union, they specify obligatory bus stops. So whatever we are doing was on the side of the law. Then, when we say we suppress the driver, yeah, it's nice. It's very maybe technically or legally it's simple. But we are providing a service, not a technology. The driver provides a lot of services to the passengers. Who will replace it? How we will do it automatically and in a non-intrusive way, inclusive way, this is a major problem, and we have to define what are those services that we really need. And then going to business, because at the end, that's where everything ends, business. The business model today that we have, they are not adapted. The public number operators, they do not understand the complete size of the task. So there are many hidden costs, there are things that we do not know, and that's where we try to provide solutions. And finally, technology is not yet there. And not even is not yet there, it's evolving. Whatever we have today in 3 years will be obsolete. So how do we take into consideration all this? So what we achieved after the 4.5 years? Well, first of all, we did deploy the first regular on-demand door-to-door public transportation service. In all the sites, we had regular transportation services. In 2 of the sites, we are still running. There's still a service there operating after the end of the project. And we proved that it is something that the passengers wanted. Second, we identified the gap on the legal framework. We see that there are many, many holes there, that they are not there, and we have to cover them. If we go from small deployments that the vast majority of the projects we're doing to large scale, well, there is a big gap. We don't know how to do it. And then we went over, because yes, technology is nice, legal is nice, but it's social and economic impact is important, and how we do it. If the passengers don't want it, it doesn't make any difference. So let's see what we did. I mean, how many sites we had. I will not go too much. There were, as you can see, the regular sites. We integrated the results from other sites that they were operating in Meran, in Geneva, in France. We ran how many thousands of kilometers with how many people around on that, and we learned. We learned a lot of things. We identified things that they need to be updated. We made baselines for the future research. And well, that's some of the data, 80,000 kilometers, 80,000, 60,000 passengers, 10 automated minibuses operating. At some point in the site, you can find all the data of the sites. We have special brochures. I can send it over. They are printed as well, if anybody wants them. And I will not talk about the results, what we find. First of all, we came up with a series of legal and regulatory recommendations to different entities, to the European Commission, to the site, to the different countries, where we talk about what is yet is missing, like type approval, accessibility, public transport regulations to change, data protection, where we are on that, competition, it's not yet there. There is no ecosystem. Civil liability, who is responsible in an accident? The law is not clear. Infrastructure that is missing. We have to install things. Autonomous vehicles require, for example, electricity. Who will install it in the city? How put the lines? Where? Spatial planning. The urban design will change. It will not stay the same, and that requires regulation. Driving permits. For you to drive a vehicle, you need to pass an exam. Those vehicles, they pass no exam. So are they safe? We see what happens with Tesla. Sometimes there are some accidents. We cannot afford that in Europe. And of course, there's criminal law. What happens if something happens in the vehicle, a crime? So all these things, we provided some recommendations. The documents are available on our site, where we explain exactly what needs to be done so that we have a, legal deployment in the future. Then we came up to technical needs. That is for the manufacturers, what is needed? Well, of course, improving the vehicles, like speed versus safety, and versus legal liability. We increase the speed, then the safety may go down, and then who is responsible? Already in the European Commission, there's a law that voted that on technical issues, it's the manufacturer and not the individual parts that they were contributing. So we are going to the same direction. Then on the technical, safe dynamic rerouting. That is something that the majority of the sites or the demonstrators did not do. To reroute the vehicle dynamically on the fly, that requires a lot of technology and thinking. You cannot give it an order, turn around in 3 meters. It needs to be adapted correctly. Cybersecurity, people talking about having, let's say, teleoperation. Teleoperation means that anybody can take control, and it will take control. So there are limits, how far we can go. Today it's niche, but if tomorrow we have thousands of autonomous connected vehicles, clearly they will be attacked. And God knows what will happen. Level 4, redundancy, system redundancy. The vehicles that exist right now, they're not exactly level 4. It's missing the auto-detection on their part. The same way that in an aeroplane, if any sensor is down, you will know it. Here, we don't. And V2X needs, how to connect, what is the standards. Fleet orchestration intelligence, a very complicated task. Yes, you can do it with 3 vehicles. What about you have 200 of them with 5,000 people, 5,000 requests per minute? And it continues over safety of the passengers. The vehicles that we were using, we evaluated, they are not safe. They need to be redesigned to allow safety for, as you can see in the example, for kids, for example. So, then going to operating without operator, well, that is, let's say, an area that it's not well anticipated. An operator, as I was saying before, a driver, provide services. So, like status control, somebody has to figure out if it's clean, if there is no tires, if there is no problem. Safety on board. Something happens, accident, aggression. That's the driver who is doing it. Assistance to passengers, incidents. Who will do all that and how? That does not only require electronic means to identify, but also policies from the operators to say what we will do when this happens. And we have to anticipate all of the incidents. Today, this doesn't exist because we have the driver who is an intelligent human being and he will take over according to his own way of thinking and some directives. Here, things are different. In vehicle services, that's what we developed. That is, we say, that is maybe the way of doing it. We have a camera inside, we have audio, video, and we can identify the security. This way, once we solve a part of the problem, but we also enhance the safety feeling of the passengers. They know if something happens, somebody will take care. I'm not going to be alone, lost in the middle of the city. Of course, all that requires technology, development, protection of private data, and policies from the operators. Economic assessment. That is the iceberg. This is where the public transport operators and the, let's say, PTAs, they don't know where we are. We know the basic things, the top of the iceberg, some legal, passenger, etc. But then, going deeper, we don't know what it is. Today, all the trials that have been made are small scale, short duration. Going from small to very big, it is not a trivial task. Many, many things are appearing, many things are not there. So we need to operate under realistic conditions, which is not the case today. So what we have done for the economic, we developed a tool, taking the data from the past so that somebody can put all the data of his city and figure out, depending on quality of service, 2 minutes wait or 4 minutes wait. That changes the number of vehicles to serve an area. How much waiting? This will allow, this tool is still under development to complete, to add more data, to understand exactly what we can do. How much it will cost you? What will be the capital expenses? What is the operational expenses? with, without a driver, distances, some of the policies. So this is something that it is there, it's available, anybody can use it. There's a lot of data to enter to understand. We have some templates already. Yeah. And what is the impact? What we do? Well, it doesn't stop there. Based on the knowledge in Avenue, based on the knowledge from other projects, Show, etc., we have a new project, Ultimo, which is to deploy the first commercial service. We're talking about, on the calculations we made in Avenue, the minimal number of vehicles at one site operating is 15 vehicles to be commercially break-even. And that's what we're going to do in Ultimo, to go beyond that, to try to make it happen, to make it realistic, and study all the questions that we identified in Avenue, we identified in Show, identified in other projects. So it's a composition of all these things. I think I'm on time. You told me 14.5, right? So I think there is no.
Thank you very much, Dimitri, and especially even for highlighting this last point that you made, how actually I will turn it the other way around, how we have projects that are now launched under the umbrella of the partnership under Horizon Europe that are effectively building on projects that were financed under Horizon 2020. This continuity is really important. Now, moving to the next speaker, I would like to call next to me Arvid Schmidt, who works for Easy Mile, where he is Director for Strategic Initiatives and Passenger Transportation. He is responsible for raising awareness and visibility on the strengths and varied use cases of autonomous vehicle technology. So he has been working on autonomous vehicles, I think, for most of his career, including his academic background. Arvid, the floor is yours.
Thank you very much, Andrea, and it's a pleasure to be here. Before starting with slides, just to motivate a bit the topic, we will speak now about autonomous logistics, and you could put that into the same box. Okay, there is something happening with autonomous driving. The truth is that, especially when you followed the recent news and when you watched in the last 15 years in the media, the autonomous driving universe is in a very changing condition. And maybe the foremost key message to shout out here is, it is really a marathon. It is nothing to be achieved in one project, in two projects, or in specific dedicated pumped up sites. It is really something where we need to work on adoption, where we need to focus the right topics and to reach the humans which shall use the technology. And all those projects, and I will focus today on Award, do have that type of same general mission to make a specific element of that value chain in that marathon happen, and to use that as a building block, as a puzzle piece to move it forward. So I could actually terminate my slides here and say, Dimitri said everything, because it is a full picture of what needs to be achieved. The truth is, and I'm representing here Easy Mile, the truth is that every single piece that needs to be developed needs to be safe, needs to be proven, validated, needs to be put into that value chain. And that systematic approach and that use case-based approach, not just thinking, okay, I'm not a child anymore and I can walk, I can see, I can do whatever I want in my environment, and now let's just do that as for a robot in university or in a company. It's not as simple as that. It is really a big step forward to master specific use cases. And the main message for Award is that we try, and we are on a good progress here, we have good progress here, that we try to master very relevant use cases with autonomous driving and with specific applications in goods transportation. And just before, very interactively, who knows the company Easy Mile? Just raise your hand. Oh, it's good. Sometimes you end up in having just 2 or so hands up. Yes. An introduction to Award, quickly. Let me open the full slide already for you. Focus on the amount of logos which you see on the bottom of the page. What we learned is that you need to focus on specific core components. If you try to do everything, it can't work. So the way how we get funded here by the European Commission and get support for this project idea is massive, because only by that we have been able to bring together the actors we need. And when speaking about the actors we need, it is here when we speak about scaling. You can't scale if you just look at the very same use case, just it looks a bit different. So you need to have complementary use cases, especially when talking about logistics. It is a chain, a supply chain. Everything is in a chain. So we need to have use cases that generate this chain. You have so many actors in that chain for autonomous vehicles that we need, that's what you see here, starting with the playgrounds. Where does it take place? The technology, who inserts which techno blocks into ours, what is the integration method? There are so many fields left and right to the main story that this is actually what we try, and we are, as I said, it's a pretty good situation to talk today about it, because 2023 will be one of the key, or the key year for the deployment of the demonstrators we have, that we bring together the right partners also to demonstrate 4 different use cases. And that's what I want to show you on the next slide. When thinking about a chain, first of all, many of you know EasyMile, I don't need to motivate it. On the top left, this level 4, SAE level 4. Without safety attendant, yes, but in a controlled environment. Just for the sake of clarification, right at the beginning, we don't aim doing level 5 here. We don't aim to have a vehicle doing everything itself, but to have a pre-programmed terrain and to let it operate automatically without safety attendants in a pre-programmed environment. That is basically the storyline, and I highlighted here what you see in yellow, the most relevant aspects when looking at this storyline. Before jumping to the yellow ones, look at the pictures. You see autonomous loading, so a forklift. Then you see a hub-to-hub transport, something that has been loaded to somewhere, needs to be transported from one hub to the other. And then it could either be transported further on an airport or on a seaport. So the idea behind it here is to have that, what I said this slide earlier, to really have a value chain. And now look on that value chain. You want to have it level 4. You don't want to have manual interventions. And you want to have it under all weather conditions. That's what you expect today, not just for public transportation. Your bus driver drives you when it's rainy. You want to know that on whatever site you are, your goods transportation works safely and in weather conditions which are partly adverse. Second, you need to be compliant to the regulation. Dimitri said it in his presentation. We need to identify which SOTIF applies here, which ISO applies here for the respective use cases. Not all of them are on public ground. Most of them are on private ground. Some are mixed between private and public. And very important is, in general, not just for award here, the topic 24/7 availability. So what we have seen, and EasyMile is a company of 8 years age, what we have seen is that the performance has been, especially when looking on public ground, often not been addressed properly, because it was focused on the techno. It was not focused on the performance and the delivery. You can do that when you play with technology in the first years before having sound operational design domains. But once you have reached that, you need to prove it, and that is, so to say, a proof for us that we can do it. You need to prove that you have the competence in delivering a real performance, especially when it comes to service agreements, especially when it comes to standing still machines, when someone is producing parts and components, and then it is you, because you are standing still, the shift doesn't generate the output it should generate. So there is really, not just from a safety point of view or from an efficiency point of view, there is truly from a superior plant management, from a superior port management point of view, there is something to achieve here. that, just to say it and connect it directly to climate change and to all those superior societal goals, which is not outside that. It is just not visible. Usually we don't think about those type of applications because we see buses, cars, and so on, but that is where a very large mileage is taking place every day, which can be controlled, which can be optimized, and which is most often easier than the ones with the vulnerable road users, because often you have control sites. There is not access to everybody on the airport. Same is true for the seaports. So it is for us, from the storytelling, it makes a lot of sense to start with more simple use cases to develop the technology, and then once you have mastered specific use cases, to build them up and to enlarge them, which is a very different approach than having nice YouTube videos where you see 120 kilometers per hour fast driving cars. And this is more like the European way to start systematically, use case per use case, but build it up and qualify it. I could go now with you through all the 4 use cases. I will just highlight the most relevant aspects here. What we in general do with the award project is that we focus on the very operation with a specific vehicle. That is what is happening here with the forklift. You see it shall be an autonomous forklift, and when I say shall be, all what you will see on the next 4 slides will be deployed first time in the second half of this year. So we have until Christmas of this year is a plan to have everything in pilot operation of the 4 use cases you will see here. And just to give you a bit of teasing, it is all with the same sensor set. So we do not have different sensor sets. That is one of the main messages here, because you could imagine if you start for every specific use case to have a specific sensor set, specific sensors in collaboration. We need to do the middleware, we need to do the respective sensor geometry, we need to prove that this is safe and validatable and that our software versioning runs on every of those different sensor geometries. It is simply impossible. Yeah? That is as if you have tons of varieties and you try to control all of them at the same time. This can't work. So what we need to have is one sensor geometry which can be applied by logic means on many different vehicles. That's what's happening here. Let's move over, for instance, to the hub-to-hub. Here it's a very interesting case. I said it early on. We have private sites left and right, and in the middle is a public street, public road. But at the end, the use case is just to take that type of truck, make it on the one side load something, and on the other side across the street to unload it. And this job needs to be done every day. That is autonomous driving. It's not as sexy potentially as YouTube videos, but this is truly autonomous driving. Here, the tracked easy, and teasing number 2, I will have shortly a video which is, to me also, with my 5 years of EasyML experience, surely the best I could show you, because it is, you will see the film, the short one on the next slide, it is actually how we measure our own success. So taking this vehicle has now 25 years of experience on many airports around the globe. Autonomizing it, that's our core competence, we know what we need to do. Making it safe and planning the operation correctly, yes, that's all in it. But what you see here on the status, sensor calibration and data comparison. At the end, you can easily, if you look into the perception system, it is a noise. It's a noise filtering method you would like to apply for a fusion sensor system. So many different complementary sensors delivering you a noise map. And you need now to be able to filter out the right, wrong sources of noise by not creating too many impacts on the basis of your software. That is actually the challenge, if we put it in a nutshell for award project, what shall be achieved here. And you read it in the last statement, the development of the fleet management system in itself. I will come back later to that. Here's a video. You see strong rain, and you see that there is, out of the sudden, someone put in front of the vehicle and it stands still. And I can tell you that most of the operations we're having experience rain, but in many of those operations, a specific amount of rain, once this is overridden, stops the operation. And here, with that, we have proven, it is a very massive piece of proving it, we can operate in this type of rain. And now, you still could argue, okay, you won't be able to do it always, in all conditions, with all types of snow, fog, hail, imagine what could be. But it is a proof that you can build a perception system so smartly that it can adapt to very different types of precipitation. Last one, you have a port. And when we speak about ports, you see moving objects, which are here the ships. But when you want to do belly offloading, so driving with one truck autonomously into the belly of a ship and just offload something, you need to think about the deployment. Because today's deployments, especially on public ground and also all the other deployments in the world, they are having one basis, which is the historical map. And in that you put the vehicles, you have other objects and so on. But here you have ships coming. So the ships need to have, or the vessels, correct language, the vessels need to have the right point of touching to where the port is. And this may not be the configuration of the two deployments, may have a little bit of confidence interval, but you can't have for every vessel simply a new deployment. So somehow you need, this is for us like a deployment 2.0 approach. You simply can't deploy beforehand everything, so every ship has its own deployment and the port has its deployment, but we need to make this puzzling of deployments. One thing, when looking into today's last mile operation, that never has been the case before. Which is, the devil lies always in the details in those projects, which is why I say let's master first specific use cases and then bunch them together into a full value chain. So that's it.
Thank you very much, Arvid, for this very, very interesting presentation. Allow me just to go back to your initial source, which were the marathon that we're on. This is true, it builds upon what Dimitri was also saying. I would say the difference with the marathon is that actually in a marathon maybe we're all competing one with the other. Here's a marathon where we're all together. Competition will come, it will come at a later stage, but for the time being we all need to work together towards this common objective, having in mind a very long-term perspective. We now move to the presentation of the next project, MobiDataLab. I'm pleased to call here next to me Thierry Chevalier, who is coordinator of the project and works for Acodis Research in Toulouse. He is a software project leader with a long experience in the design of RESTful web services, of geodata APIs, and web mobile map applications. And during his career, he's been working in the domains of geospatial technologies, journey planning applications, mobility data science, and many other things. Thierry, please, the floor is yours.
Thank you, Andrea. Good afternoon, everyone. So I will be talking now about MobiDataLab, which is a project dealing not only with CCAM data, as Andrea just pointed out earlier, but mobility data at large. So what are the goals of this EU-funded project? Is first to foster the sharing of data amongst mobility stakeholders in Europe, develops knowledge as well as a cloud solution aimed at easing the sharing of data, collects and analyzes the advice and recommendation of experts and supporting cities, regions, clusters, and associations, and finally conducts agile exchange sessions aiming to co-create, explore, and experiment with mobility data. Just to let you know that the project started 2 years ago. Now we are entering the third year of the project, which will end by the beginning of 2024. So as you can see, this is a consortium of 10 partners with a lot of different disciplines represented. And I think that's really a peculiarity of this project, is that it is not only technological, but cover very different fields, because data sharing is quite a broad subject. So coming back to the objectives of the project, what will be and what are the outcomes of the project at the end? First, a knowledge base, an open knowledge base to be more precise, And in this knowledge base, you will find the mechanisms which enhance data sharing in the transport sector, and the knowledge of how to improve the findability, accessibility, interoperability, and reusability of mobility data. I will come back to these terms a bit later because they are just like paramount when we are talking about data sharing. And they are sometimes referred to as an acronym which is FAIR. Second objective of the project is to prototype a scalable cloud solution for sharing mobility data, which we have called the Transport Cloud Prototype, and to showcase the most effective means to access and exchange mobility data. And the final objective, and it's what we are really concentrating on in this last year of the project, is just living and virtual labs, which means innovation sessions, gathering representatives of data providers and data consumers, and conduct innovation sessions to co-create, explore, experiment, and using data as a tool. So, if we go a little bit more into the details about these results. First of all, the knowledge base. As I was mentioning earlier, MobiDataLab aims to really be multidisciplinary landscape of the data sharing ecosystem. So we are dealing with two kinds of knowledge. First, what we can call a state-of-the-art in terms of legal and governance, which means all the regulations coming out in data sharing, recommendation on legal frameworks, data governance. First is legal and governance. Second is data privacy. It's really a big barrier to sharing data, is the confidentiality of data. So here we have partners exploring different anonymization techniques with privacy by design strategy and how to guarantee privacy while sharing mobility data. Standardization is a whole topic in terms of sharing data, because we are dealing here with interoperability. The easiness to exchange data means easiness in terms of format of data exchange, technologies, etc. So we are also exploring cloud solution frameworks. In this knowledge base, we have evaluated 20 solutions right now enabling the sharing of data. We're also exploring use cases. 10 concrete use cases have been explored. I will just describe them, not all the 10, but just to give you an insight about what it's all about. And then we've got a second kind of knowledge, which is more related to business models, to market, to the needs of the actors. So we conducted a market study about the main products. We performed a gap analysis with the actors' needs, the needs of actors in terms of mobility data, and also exploring business and revenue models. So what kind of use cases have we explored? So the first one was the optimization of transport flow and what we call the estimated time of arrival. Second is the emission reporting, which is very important because a lot of cities in Europe are just, and in the world are just setting up low emission zones, as you know, and the sharing of data in this context is extremely important. Analytics and learning, which is quite broad in terms of what can be decided afterwards, and it's just like something that is very, let's say, not a priori deciding what could be learned from sharing of data, but rather just try to explore everything that can be done with data. We also pay particular attention to the improvement of journey planning services, and mobility as a service, as journey planners, is a building block of mobility as a service. And we also studying use cases for research, in particular how data sharing can improve the inclusiveness of transport, improve accessibility of transport, improve the sustainability using specific technologies like linked open data. I was mentioning the transport cloud prototype. The idea here is just like to provide to users the most efficient means to achieve findability, accessibility, interoperability, and reusability in the context of innovation sessions, as I was mentioning about before. So here we are dealing with what we call the Federation of Cloud Services. There are a lot of cloud services all around, a lot of data sharing platforms, and let's say, enrichment processors that can be just gathered together in order to perform sharing of data in an efficient way. So one really key component of this data sharing platform is catalog. You need to have access and to find data as easily as possible. So this is performed through metadata and service catalogs. Another key component is privacy and anonymization tools, because you will not be able to share data if you're not guarantee that you are able to anonymize properly data which will be included in the platform. And then data enrichment, because when we are talking about sharing of data, even sharing of transport data, the actors are not only in a transport system, but also from other domains. For instance, you could have people from or data providers from the environment field, data providers from the insurance field, from the urban planning, from the energy sector, also to just like assess the best locations for putting chargers. You could have tourism, etc. These actors are endless, actually. So regarding the catalog of metadata, here we are talking about findability. The key components here is what we call open source catalog solutions like CCAM, which is the most used open data portal, but there are other solutions. But here we are exploring the interoperability of catalogs, and this is the key issue, because you have several solutions existing. Here I mentioned CCAM, GeoNetwork, Open Data Soft. In North America, you have got Socrata. Once you are storing data in your catalog, you need to be able to communicate in between catalogs. So this is what we are doing, just through a process which is called harvesting of metadata, which help us making data available in whatever language possible from various sources of data. The same for the services, because we are talking about data, but also mobility services, digital services, let's say. For instance, routing services, geocoding, which means translating a coordinate, an address into coordinates like latitude and longitude. Traffic services, one of the most well-known are just like OpenStreetMap APIs, Google Maps, Mapbox, etc. But all these mobility services are endless. And here, interoperability is a true problem, because there is a wide heterogeneity of services right now, and which are not quite interoperable between others, which comes with some problem. For instance, if we think about mobility as a service, just switching from one journey planner to the other in a mobility as a service solution is problematic, because they are not speaking the same language in terms of technology. So we are working on easing this interoperability. Also, when it comes to reusability, we need to be able to enrich mobility data with data from other sources of information. For instance, we were talking about all-weather autonomous mobility. So it's indeed, it might be useful to be able to combine data from the environmental field with data from the transport sectors. So here we worked on two types of enrichment. The first one is called semantic enrichment, the second one geographical enrichment. What is the difference between them? Actually, the combination of data sets on the first solution, a semantic enrichment, is based on a common vocabulary. Identification, for instance, of a same object based on a vocabulary, and the other one is on geographical coordinates. We assess that, for instance, this bus stop in OpenStreetMap is the same as this bus stop in this journey planner, and then we are able to, for instance, combine the information and assessing a better quality. For instance, we found sometimes a lot of differences related to accessibility of bus stops information, depending on the sources. That is very useful for quality assessment. Regarding anonymization techniques, our partners, which is expert in privacy preserving techniques, has explored different techniques for preserving the privacy of trajectories. So this is the famous data sets from taxis in San Francisco, which is just like anonymized through 3 different techniques, which is the first one, swap locations, when you permute location trajectories among other trajectories, swap mob, which is swapping segments of trajectories with other ones, and what we call microaggregation is partitioning the dataset into disjoint clusters. The idea here is that you have anonymized datasets in the end, but what is interesting is that the statistical properties of the dataset are preserved, which means that you can still perform analysis on the datasets even though it is impossible to find out what was the original trajectories. So this was for these tools we propose to give to our users. And then in which context will they be used? It's in what we call living and virtual labs. So here we would like to gather, and we are gathering actually, transport stakeholders on the one hand, thanks to our police partners, which is currently gathering cities and regions as data providers. And on the other hand, we have F6S, which is a network of startups, the biggest network of startups in Europe, which gathers SMEs and startups, innovators, and that will, in the context of hackathons, datathons, and codagons, we were talking about marathons, so just like another ones here, just trying to find solution using all these transport cloud components as a tool and open data to the concrete mobility problems proposed by mobility stakeholders. We have the city of Milan, Eindhoven, Leuven, Malaga, Rome, Trikala, which are just like proposing challenges or contextualization of the use cases and try to find solutions to these problems. So this is just like a roadmap for these X-athons to take place this year, the first one being next month of May and September, and then ending up in what we call a codagon, which is a kind of hackathon taking place during several weeks. So, just have a couple of slides to end with my presentations about the expected impacts of the projects. So, basically, what we want to do is consolidate knowledge. It's just like documenting the achievements from all the mobility data projects we explored, so more than 100, referencing data sources and services for the transport cloud, which means that everything is accessible through our metadata catalogs, so to be further used for other contexts, other possible applications. Again, we are doing an open knowledge base, which means like a bit like Wikipedia. We want to have contribution from everyone, every stakeholders. The idea is based on this knowledge to improve services and products. So we have in the consortium 2 service providers with journey planning and map service providers, which will, thanks to this knowledge consolidation and innovation sessions, be able to improve their services and products. And this is the case for every mobility service, which is depending on the same data sources. And finally, foster the data sharing culture, which is really the most important objective of the project. So by surveying mobility data providers and consumers, collecting feedbacks, and interacting with the mobility data community. So MobiDataLab is not alone. As you can see, we rely a lot on the advices of our advisory board of standardization bodies and clusters like Mobility Data, UITP, La Fabrique des Mobilités, Ertico, etc. And also we have established cooperation with other projects, which is still extending. And that's it from my end. Thank you for your attention.
thank you very much, Thierry, for this, and I think your presentation has managed to raise awareness on how the data challenge is really one of the biggest challenges that we have when speaking about future mobility, how to transform data into actionable information, something that can be really used, and the other dimension, which is the sharing of data, which needs to be fostered, even among purely within the research community, when possible, when appropriate, we need to find a way of sharing data. This leads us now to the last presentation of the series, which is of project nuMIDAS, and I would like to call here next to me Sven Merriwood, who is the coordinator of the project, and he has over 20 years of experience in the field of traffic engineering as a researcher and as a consultant. He has an extensive experience in coordinating and reviewing EU-funded research projects and is also a member of the board of directors of ITS Belgium and former chair of the Belgium Mobility as a Service Alliance. Sven, the floor is yours.
Okay, thank you all for joining. I'll be your last speaker before the heated, intense debate hopefully starts. They will make sure it will work. Let me quickly recap the nuMIDAS project. It's a Horizon 2020 project that ended actually December last year. It ran for 2 years and it was part of a call in which we were to look at what happens regarding different kinds of data sources that are now existing. There is a plethora of data already available, as has been shown by the previous projects. Our idea was, can we do something to integrate all this data? And this is especially true for cities and policymakers. They sit on a lot of data, but they not always have a fine idea of what to do with it or how to optimally use it. And this is where our framework, let's say, comes into play. We are a consortium of 9 partners, a bit spread around Europe. There is the Netherlands, there is Greece, there is Spain, Italy, and then Belgium, of course. And Czech, we are with the 9 people. All of them had their specific place in the project because there were a lot of different tasks that needed to be completed because you are on a 2-year project and because you want to create a certain amount of, let's say, differentiation within the projects that we developed. In order to test all of this and to make sure that what we created is actually going to be used by policymakers, we deployed it in a couple of cities. These cities, they were Barcelona, Milan, Leuven, and Thessaloniki. Each of these cities, some of them are partners within the project, others they were via a partner that we already had in the project, but we always supported the cities, and this is an advice that I can give to everyone when you are joining consortia or when you're creating these kinds of proposals. If you have cities, make sure that you also have local partners who understand how the city works, because a city is a policymaker, is a public body. It's not always so easy to interact with. They cannot move as quickly as the private sector, and there it helps if you have these, let's say, these links with the local partners. The first thing we wanted to do before we created what we call the Toolkit, which is the end product of this project, is to figure out what are we going to do, which are the problems that we want to address. Just getting a grip on what mobility problems exist, that took almost a year. I'm sure that if I ask you for 5 minutes all the mobility problems that you come up with, that would go very well, I guess, and everyone will shout to me this and this and this and this. But then we have to figure out, okay, but what's the commonality between them? What is the exact challenge in this thing? Has it been solved or has it not been solved, or what are we waiting for? So just to figure that one out and to figure out not just what we think are problems, but what the policymakers, what the cities think are problems, that is a different thing. So in order to do that, we did some use case scoping, which took quite some work in order to figure out what we wanted to do. In the end, it boiled down to, because we are a 2-year project, and that's another thing I can tell you, if you have a 1-year project, forget it. You can't, it's infeasible to do something in 1 year. If you have a 3-year project, then you have the nice luxury of having 3 years. And if you are at the end of the 2 year, you still have a year to do whatever you want to do. If you have a 2-year project, time is of the essence. The first year it goes by really quick, and then the second year is there, and then you still have to do a lot of things, and to get all of that implemented, it is there that you realize how high the stakes are that you wrote in the description of action and in whatever the Commission expects of you from the call. So in order to deliver, we looked at what kind of use cases are feasible, what kinds of use cases are useful for those cities. For Milan, the question was really very specific. If we are going to write tenders in which we want micromobility service providers to go to the market and to provide, for example, e-steps in the greater area of, let's say, Milan, how much do they need? How much steps are needed? So that's a question of transport demand and supply. Another question is, where do we provide them? Milan is quite a large city. If you look at that, is it more towards the north? Is it to the south? Or their preferences? What if you have multiple competition? How do they cooperate together? All these things have to be taken into account. Another question for Barcelona was they were sitting on top of a lot of data that was stemming from cameras and some loop detectors. They wanted to figure out, could we do something useful with it regarding estimating the emissions? They had several emission stations, but they, as you mainly know, emissions are typically measured at certain spots in the network. Here the idea is, can we have a more refined view of where the emissions are taking place due to traffic and other sources, for example. Another issue was how many vehicles are driving from one point to another, which is a classic origin-destination matrix. It seems simple, but in order to infer that from simple counts, etc., you need something, a specific model that can take care of that. And this was exactly what the city needed in order to get a grip on what is actually the demand. Because for now, they only know where the people are driving, at what spots, but they don't know what the big travel patterns are. Leuven had a very specific case. It's a city where I live. If you go by car to Leuven, that's a kind of a masochistic behavior, trying to find a parking space. You can try to find a parking space underground in a garage, that works. But if you want to, say, for example, park in the street, that's more tricky. Further on, there is this movement towards greening the zones, etc., which means that there are effects when you remove parking spaces. But what are those effects? And we're talking about really specific things, not just, let's say, a high-level blah, blah, but really figuring out, if I remove 10 parking spaces in that street, where is everyone going to go to? Of course, we can imagine that they drive towards the regions around it. But it depends. What if there are barriers in between? What if the parking availability is not the same as before? How far does this spreading out effect go? And you can immediately, just by thinking about it, figure out how complex this system can become. And in order to cap on that a little, we just said, okay, these are the assumptions we make, and this is how we will do it, and this is how you work with it. And of course, you can extend these kind of things, but these kind of use cases can easily become a project on their own. For example, in the Thessaloniki use case, there was a question, can we have a tool that can pre-calculate the impact of traffic management measures? What if you lower the speed in the entire city to, let's say, 30 kilometers an hour? What if you change the traffic lights in the city to new traffic settings? Can you model this with a microscopic simulation model, and can you then estimate what the effect is going to be? In order to do all of that, we had a group of people working on the specific modeling questions. So take into account, you have the end user, they provide their user requirements, that needs to be translated to system developers that somehow can work with that. And then there is this loop in order to make sure that whatever you build still answers to the questions that were originally posed, and that you build a thing that can actually solve the problem that you had at the beginning. So in order to do that, a lot of time was spent on figuring out how the models work. I'm going to quickly skip over some of these slides. You can have them at the end, and everything is publicly available on the website should you want to go into further details. Just for example, in Leuven, you see this effect. This is, let's say, before, after. The left side shows a baseline where you see the occupancy. Red is highly occupied, and then green is less occupied, which is a typical plot for, let's say, a city where the center is more dense, more densely occupied. What happens in certain cases if we remove certain parking spaces? And you can have different kind of flavors that you want to include there, and then you can do a before and after comparison. In order to do that, we just because a toolkit needs to be useful and it needs to be used. So if you think about technology acceptance, a huge part of it is in HMI design and also in user acceptance and acceptability. So here the question is, how are the users, are they actually going to use whatever we build? If something is built solely by developers, it will work definitely for the developers, but maybe not for all the users within the community, for example. So here we had storyboarding, interview, user testing, the entire cycle in order to have a product that is actually usable and very, very important, marketable, because there is always the idea of exploitation after the project ends. So you have to keep that in mind early on. The toolkit itself, it's more technical, it lives in the cloud, so everything was hosted by Amazon Web Services. We had a partner that was excellently versed in creating these kinds of tools, making sure that everything interacts. So there was an entire backend setup in order to make sure that the system remains stable and that it remains accessible anywhere in the world, let's say. On the other hand, because you work with 9 partners, and typically European partners, it's not that they have an extensive background in working together, let alone in developing a computer product, let's say, a program. You need to have some definitions, standards, and at least some guard, someone that says, no, we need to do it like this, or we have to follow these kinds of guidelines. That also had to be developed during the project as we went along in order to make sure that whatever coder A creates is interpreted and used by coder B in the same sense without creating extra problems. In the end, there was an extra layer added. For example, if we have a solution in Milan, but we want to deploy that to another city, we need to make sure that people from another city can access it, that they can manage their own users. Suppose that someone new joins the club, they need to be added to the system. All of that user management, etc., was also a separate task within the project in order to make sure that that went quite well. Now, in the end, what it boiled down to, all the work after 2 years resulted in a toolkit that lives online, that has complete access covered in order, user management access covered. People can log in, we can log in and see everything. People from Barcelona will only typically see the parts from Barcelona and from other cities, so it's, let's say, segregated between different cities. Within each city, there are these use cases implemented. You can, for example, the thing I said earlier about how much micro-mobility services do we need to provide, for example, how much e-steps do we need to provide, or kick scooters or whatever. The tool calculates the optimal number, and it calculates also the net values, the returns on investment, etc. that it's going to cost. So there are also macroeconomic indicators attached to these kind of things. So it's not just the bare bones, but there is also this societal aspect that is taken into account. The same goes for once we know how many we need, the question becomes, where do we want them? So in order to do that, we created also a second tool that is based on the previous one that now just also not only calculates the number of, let's say, steps that you need, but also where you need to deploy them. And the end user can still provide, let's say, preferences. I want more on the east side or more on the west side, or I do not want to include this zone, which becomes very specific when you are trying to give a tender to different parties and you have multiple cooperations and competitions. For the planning for the parking, this is what actually the interface looks like. So the block diagram that you saw earlier, it was a pre-concept visualization. This is what it actually looks like. So people can just click on all these individual streets. They can figure out, okay, I want not 10 parking spaces, but only 5. Then the system automatically remembers everything. Then you do the calculation, and it will tell you where the parking pressure has increased, where it has decreased, and how it evolved. And this is actually very useful for policymakers, especially in Leuven, for example, where, as in many cities, some policymakers have an idea. Sometimes the idea is global. I want to do this for my city. Sometimes it's very local. That specific part in the city is a problem for parking. Can we do something about it? And up until now, it was like with a wet thumb, like we say, wet finger, estimation, what may happen. Now Leuven has a tool in order to calculate these kind of things. For us, in the end, it is important that whenever when we talk about data, there's a lot of data available, but it needs to be integrated somehow, and it needs to be easily integrated. It doesn't work if you have a tool that is very difficult to copy, paste to other regions. There must be something that is let's say, generic to everything. And this is what nuMIDAS actually worked at. We have a generic part, but we can incorporate whatever use cases we can have. So if you look at the previous project where they talked about the data integration, that challenge is still faced with us, and it would help if these kind of, let's say, standardizations or data integrations happen before you go and do this within the city. And then finally, it depends who my audience is. If the audience is filled with policymakers and city representatives, I try to sell them this thing because this is what we want to do from an exploitation point of view. The project may be finished, but the group hasn't finished. So now we're working on the second stage, which actually means that we need to deploy this in other cities. We enter into different partnerships. We also enter into horizon proposals in order to make sure that the project can continue and that the toolkit can live on and can be further refined and used. In any case, you can find everything on the website. There are nice videos and everything made. And if you need to ask me anything, either I'm here or ask me later, ask me by email, doesn't matter. Thank you.
So thank you guys for a nice overview, for clear presentations. I think we've heard a couple of quite diverse things, but also some common struggling or common issues working on. We've heard on services for cities from several of you, addressing their needs. And though you didn't say it specifically, I think you are doing it partially in a co-creation approach. We also heard you, at least two of you, talking about joint approaches, at least in the consortium, on data handling, on the struggling you have on making the data anonymous, and then how to make it findable and useful for the users, for the cities. But also working towards specific and useful use cases, challenging enough to try to jointly make a next step in our marathon. Yes, we'll use that one, thank you. How to do that. But also things that we've seen that you've come across and made more specific are questions on the business models to make it economically viable as well, the services you're providing, but also thinking about what services do you actually want to offer and to whom are you offering those services. So I think we've heard some answers and some new questions, which is the challenge that we have in our step-by-step approach. I hope they were very clear, but I hope that also raised some questions on your side, because this is the point where you are supposed to do some of the talking. Do you have any questions for the speakers? You can raise your hand. I thought I might have to unplug the microphone, but unfortunately, Margina has a microphone. So who's daring enough to raise as first one the hand? Tom. Thanks for saving us here. Though not everyone may know everyone in the room, so if you can say your name and affiliation and the speaker you are referring to, that would be helpful.
Thank you. My name is Tom Alkem from Map Traffic Management in the Netherlands. And I have a question for you, Arwed, on the award project. Can you give us a sense of the required redundancy of the sensors needed to have the vehicle perform in those adverse weather conditions? Do you need like twice the number of sensors or 3 times the number of sensors, or do you need different type of sensors? I saw the video had only one LiDAR. LiDAR doesn't always work good in wet conditions. And do you do a lot of sensor cleaning?
No? Perfect. Thank you for that question, and it's, I think, one of the most trivial questions when you look at us humans. How many redundancy do we have? And ideally, this would be the moment to push the button and say, my reply has been there. The problem is that this is not the state of development. So I always tend to compare the autonomous driving developments from today to what has been automotive development 1890. People have been on something that looked like a coach with wooden parts, And then they thought, okay, that's a new automotive revolution. And today, this is a bit the situation 2023 for autonomous driving. It looks better. We don't look like sitting on a coach from earlier, but it still is in those early days. And yes, sometimes you need to have complementary sensor sets, but what we try to avoid is having full redundancy. So we don't have a redundant sensor set. We don't copy it, so to say, as you know it from your RAID systems or so, and when you do data management. We have so complementary sensor sets that we do the rest with a cognition system behind, the noise cancellation, so to say, what I was referring to on stage. The question if it is needed at the end for functional safety to copy sensors, that is something that is not yet answered. I can just answer it for EasyMal. We don't have that in our methodology because we do have two sensor levels, the one that is like the consultant and the other one that is the safety system. So we decouple on the perception level, you don't have the safety. It's a bit what we have with our nervous system, so our brain, what we see with the eyes, may not tell us always the truth, but based on our neural system, so to say, when we are on an icy surface, we go into the knees. Not just because our eyes are telling us, go to the knees now and give you more stability. And that level of, so to say, cognitive intelligence is not yet implemented because we are far more hard-coded. Take a sensor, do the middleware, do the fusion, put it together, do a perception algorithm on it, clean out the noise, and so on. But I hope that in the next decade, and that's far behind what Award can deliver, that at the next decade we also come to a cost-efficient sensoring. Because if you continue your thinking, you would need for every specific circumstance a specific sensor, which is just costly, and which both in logistics operation and in public ground operation on passenger transportation side won't be justifiable on economical level. And I think it was you, Margriet, who was the last speaker. Someone said it about the economic viability. The pressure on the logistics is there, but also on public transportation. We are used to have years of where concessions on public ground simply end in the city pays for the concession. The question is, and not just because of the supervision of a fleet control is better than what is today in place with the human driver, so to say. The question is which efficiency lays in the autonomous driving itself. And if you try now to have 20 sensors, you simply corrupt this hope. So we need to work on it.
Tom also had a second part to his question, like how often do you actually do sensor cleaning?
You're right, the eyelid is not invented yet. And I remember 2011 doing for Siemens also a cleaning of photovoltaic systems in Saudi Arabia. A robot climbing from one photovoltaic panel to the other one. You can transfer exactly that question to the 2023, how do you clean the sensors? We do have in our operational routines in the morning that the one in charge for the shift cleans the most visible sensors. But yes, if you would be in strong rain condition, afterwards you need to have a hub visit to clean this. And yes, ideally, once the sensor technology is more advanced, which is not our turf, so to say, we are dependent a bit on that development, there need to be cleaning instruments integrated into the sensors, yes.
Thank you. I see next question from Ro. Yeah, we'll use the microphone so everyone can hear it well enough.
Hi, this is Mehmet from Logica. I have a follow-up on that question. When we talk about these neural connections and decision systems, there are some existing systems that maybe we could call autonomous systems, like an elevator or a conveyor belt or a cable car, that do not have itself many sensors, but the infrastructure itself has enough sensors and decision-making systems. So to the extent that you are narrowing down the use cases to achievable objectives at higher TRL levels, where do you think logistics is? Are we talking about sensors that are really on the vehicles, or are you dependent on the infrastructure that represents some sort of a rail or cable system, let's say?
It's two different questions. To answer the latter one, no, we don't rely on infrastructure at all. So, because that is an additional layer of economical problem for us, because then if you start use cases based on external infrastructure, you need to have always the same outfit, which costs money, and yeah, we try to avoid that. The elevator discussion is more difficult because now it goes also into the question of approving technological systems. How long does it take in Switzerland to approve a specific part of a train? Trains usually have 8-10 years of approving time until you have another segment of a train approved. An elevator is maybe not as complex as a train, but it is all linked to the safety chain you apply. And the use case always comes with a specific safety request. So your question would relate to the classical AGVs out of the 1990s. We have vulnerable road users which are part of the game and which we can't just carve out. And even with very simple use cases, you still have humans around. Yeah.
Even in the port, which looks like a factory area.
You are right that in an optimized fleet-controlled port management, in the future, you potentially don't have any human intervention. Today, just talking about loading and unloading, coupling, decoupling, there is often manual intervention. Just if we take the track easy, it's not the seaport, it's the airport. But if you want to have, you know that trains are configured for the specific use case. Same is true for how many trailers do you need. If we take that little vehicle you have seen, what we call it the tracked easy, there is the ability to hook manually 5 trailers on them, and each of them could carry 1 African elephant, which is quite nice. If you think about 5 African elephants, but you don't always need to have this 25 tons. Sometimes it's enough to have just 5 tons maximum load. So you need to have this unhooking ability. Today, this is not automized. Today, we need to make it manual. So with the clients we're working on, or if looking into a ward project, it is always a specific check before the project, how much manual intervention do we have? That is something that needs to be worked out in the next years. We are working on an automatic coupling and decoupling. Ideally, yes, again, an industry-wide, or for us, for the platforms, adoptable solution. But you will, for the next years, definitely always have manual intervention, and it is a dream to have a seaport management completely without any human intervention.
Thank you.
To be honest with you, the reason I asked is because we are working on designing a pilot in a sort of digital twin port area, and I was wondering how we could make use of your current work.
Let's talk
there.
after the session, maybe.
That's already a nice follow-up indeed. Thank you. A next question from you, from the audience. I see a hand in the back. Margina, you have to do some exercise. Okay, Xavier is helping out on the last row. Sorry, I can't see who you are. I'm really sorry about this.
Sorry, Guus Arts, Draftdrugs.
Guus.
Hi. Question about safety and residual risk for autonomous vehicles. If you consider in autonomous vehicles, there will always be a residual risk. So maybe a question to EasyMile. What's your opinion on how to handle this risk? Knowing that the vehicle will be much safer at the end than a vehicle that is driven by a human. But still, there's always some kind of behind
This is the most elementary question you could ask. And Andrea will confirm that this safety target discussion in Europe, as safe as humans, 10 to the power of -8, 10 to the power of -9, being safer as buses. There are so many answers. This is a question of regulation, United Nations question in Geneva, basically, for the respective working group. And we need to strip it down, because if we try to find a global reply covering even American companies doing autonomous driving with their going to market strategies, we will never end up in having one, so to say, global safety approach. But out of what we learned in the last decade in Europe on autonomous driving, we need to find our approach for it. And yes, speaking for EasyMile, we fight for the most conservative approach. That means a validation by the design based on the ISO 26262, saying that only if you accomplish a functional safety analysis based on that, you have the right to do specific use cases on public ground. This is something to be investigated specifically with the respective authorities. It might not be true for a seaport, as a private ground, for instance, or for other areas, but we need to, there is not one autonomous driving to be pushed in all specific geographical areas, but you need to look very specifically what do you need. And at the end, if we also speak about adoption, that's something we haven't touched on yet because it is often focused on techno topics or safety topics. But at the end, if we lose another 10 years, the topic is maybe not as relevant as we think it today, because we see how many macroeconomic factors are coming, and also the livability of the topic. There is a financing mechanism behind. We have now.
Sorry, it just brings across for me the question, like the safety issue that Guus is raising. Dimitri, did you come across that? Because you have been driving on the road, providing on-demand services. To what extent did it come up?
Yeah, that is something that actually the imagination of legislators is coming up. They will accept that if you have a normal car, there will be accidents. If there is a bus that is killing someone, nobody will stop the whole bus service. However, we saw that minor accidents with autonomous vehicles, they stopped the whole service. So they imagine that because you have autonomous vehicles, there will be no more accidents, and that's where you have to reach, which is an illusion. We're trying to pass the message, accidents will continue, safety will not be 100%. People, yes, sorry to say, there will be mortal accidents, maybe, but we have to go on. We accept this risk. It's more risk management. We cannot go to zero, because if we try to zero, we can continue until the next 1,000 years. We never reach it. So safety is important, but we have to put limits, and the legislators have to accept that there will be still accidents. There will still be problems. I mean, look at the aviation. There are many accidents, but we're improving every time. That comes for, in the original discussion in the beginning, talking about a global database, to have all those accidents, all those issues, and learn from that and improve slowly. That does not exist. That's one of the recommendations that are coming up.
Did you have discussions with the cities where you have your use cases on safety? Did they raise it?
Oh yes, so we had discussions, because not only the city, the federal authorities, that's why they limit the speed of the vehicles to no more than 25, 30 kilometers, although they can go higher, say that's how it is. They limit the regions, they limit just to go to the bare minimum.
Okay.
So they are very conservative, and actually a city politician cannot take a risk. So it's better to say don't do it than go on. We are not in the United States.
Yeah, true. Thanks for that. Next question.
If I just compliment on that, we are not in the United States. When we had the project in Berlin on public ground, we could have said it's the very same as we had it in other federal countries already in Germany. But the clerk from the authority looked in my eyes and said, I want you to sit here in person. I want you to give me your name. If whatever happens there, you are my person here. And that shows the non-maturity of safety, so to say, in terms of formalization to autonomous driving. And it is really, as Dimitri said, a city to city, if we speak about public ground. It's not a ward now, it's public ground discussion. It is really from city to city differing in Europe as of today.
Yeah, thank you for that addition indeed. Any further questions on the 4 projects presented? Sorry, you. I see someone waving at the back, but it's very kind, but the lighting is very complicated. I'm really sorry.
Okay. Hello, my name is Sally Hadzakis. I'm from Trilateral Research. I have a question for all of you. Might be early days for you, but I was wondering, what are you doing for the disabled people? What are you doing about the accessibility and the inclusivity for all? 1 in 2 people above 65 have some sort of disability issue, and 1 in 5 in the ages below 65. So it's not a small amount. It's 135 million people in Europe, and that does not include other people like mothers with prams who have similar sort of requirements. what are you all doing about this?
Good question. Who picks up the glove first? Thierry?
Yes, thank you for the question. When it comes to data and public transport, let's say, there are a lot of initiatives, but sometimes they are more in the what we call the crowdsourced communities. So this is, for instance, in the, I don't know if you know the OpenStreetMap ecosystem, which is like the Wikipedia of Google Maps, let's say, that like just open data, crowdsourced data. There are at least 10 initiatives of people mapping accessibility of stations and challenging public transport operators with their the data they have or the accessibility information. And this data can be used to improve, well, first to assess the level of accessibility of given cities in Europe. There are a lot of disparities. Just 2 days ago, there was on the TV news in France, there was just like a comparison between Paris and Berlin, for instance, which was really not in the advantage of Paris, so to say, about the status. And then these data are used for throwing light on the situation. And what is very interesting is just like the crowd is improving this. So in the project MobiDataLab, we are trying to, that's why we are providing data enrichment. We want to be able to connect or combine data from, let's say, open data from the public transport authorities or public authorities at large with this crowdsourced data and then compare. Is this the same information? And when it's not the same, who is right, who is wrong? And then it's how we deal with this is just like improving the quality of data with respect to accessibility of bus stops, metro stations, curbs, whatever. I don't know if someone wants to.
Just one comment. I haven't heard your first name, but please connect to Guido Di Pascal. Guido, if you're still in the room, just raise your hand, because Guido organized last week a panel for Pave Europe covering exactly that topic, disabled people, autonomous vehicles in Europe. So he's your right point of contact.
And I think he's creating more and more noise on the topic, so it's good that we all are aware and working together on this. So, yeah. Any others answering the question? Dimitri.
Yeah, well, that's something that it was de facto used, we needed it. We talk about public transportation, and by law, public transportation must be inclusive. So that is one of the first problems we try to figure out in Avenue. We took some basic use cases, blind people, handicapped people, pregnant women. No, they're not handicapped, okay, it's special needs. And we came up that there is very, very complicated implementation. For example, people in a wheelchair. Yes, we did have a ramp. However, we realized that according to the laws, the ramp was not legal. The law is clear, saying the person in a wheelchair must be able to enter the vehicle on its own. That means the degrees, it's 10 degrees. 10 or 15 degrees. 10 or 15 degrees with the height of the vehicle, it means 5 meters ramp. Impossible. This is not practical. So somebody has to push him in. The other way, that's say, to have on the same level of the sidewalk as it is today. Well, we talk about on-demand door-to-door. There are no bus stops, so there is no infrastructure. So I have a problem there. For blind people, yes, we had from Siemens, they identified all the issues, they defined how they can access it by audio, how we can include information, audio information, so it is possible to treat it. We need to adapt the vehicles. And then for people with special needs, well, that is again another story that we have to identify the special needs. So we have a long way to go, but then if we take existing public transportation, has anybody of you been in Paris to take the subway with a baby stroller that I had? You cannot exit the subway. There is no way. There are stairs going up. So people with a wheelchair, they cannot practically use the subway. And in many European cities, it's exactly the same thing. The infrastructure is not there for the existing transportation. So going to autonomous vehicles will simply make things worse. So I have to go what it was in the previous presentation. You need a public policy change, adapting the whole infrastructure of the city. Go to the politicians and say to put all that money in. Then practically, you may have seen vehicles, buses, they are able to just go down, so they're reducing the distance from the sidewalk. Well, the autonomous vehicles cannot do that for the time being, so I have to change the design. So that's a design structure. I have to modify the vehicles. So we have a long way, even to make existing public transportation accessible. So adding autonomous vehicles might help.
I see you do trigger Arwed.
I could seamlessly, because the thing is, we had exactly that discussion, and you need to know that from a conformity point of view, a wheelchair is calculated with 150 kilograms, and a human in a wheelchair is in the conformity calculated with 200 kilograms. So that makes it a 350 kilograms. And in the test catalog, you need to absolve to get that conformity. You need to have 8% and an emergency stop. So not only static, but a dynamic. So what we need to do is exactly what Dimitri was saying. We took our shuttle, and many of you might know how it looks like, and just at the end, when you come into the shuttle, you just see that in the floor you have a little metal piece where a wheelchair can be hooked into. But the base construction to allow that we got the conformity on public ground to get someone with a wheelchair into it was for us a test. We did that with IDIADA in Spain a couple of years ago, to have. You can imagine driving full speed, I think it was around 10 kilometers an hour, and then an emergency stop triggered, and then the 350, it was simulated with sandbags, 350 kilogram sandbags together as a massive move-in weight, and there might not be any deformation of the carcass. And that is basically when speaking about disabilities, and we are not in a type-approved system with those shuttles yet. Yeah, with those vehicles you have seen for 25 years of operation on airports and so on, it's a different question. But for public ground and disabilities, it is really to have specific test campaigns for specific needs. We had another project for blind people and so on and so forth. So it's an important topic, but it is really, it takes a while until you develop the right testing catalogs for it.
Thank you. Sven?
The good thing is, there has to be good news as well.
Good news too, yeah, that's good.
But digital inclusiveness is baked into many of the projects automatically by the Commission. They require it, so you need to spend time to it. And it goes much further than just, let's say, physical disabilities or other impairments. You also have digital illiteracy, for example. What if you have language barriers, these kind of things? All of that has to be taken into account. So it also has an impact on the data side as well, for example. And especially for automated driving, you also have the trust aspects and everything. So also there, that is going to be included or is included already. So that's a good thing.
Yeah, just to correct you, you're right. For special needs people, there are laws defining how you have to do it. Digital literacy, there is no law. If you cannot use your mobile phone, the state will not say, you're obliged somebody to do it. It's your problem. If you don't have, let's say, validation for your mobile banking, sorry, you don't use it. Go to the cashier, that's all. So there is no law to make this adaptation. Well, for special needs people, there is law for public transportation. So there's still another gap over there.
True, and that's, I think, also why we need to have the discussion going to make sure that we don't leave the gap when we go to further deployment, I think. I thought I saw another hand in the audience. Yes, here, the front row again.
I hope I'm not asking too many questions, but what are the TRL 7-8 level solutions that you could think of? The reason I'm asking this is because some of the new calls are specifically asking for CCAM related connections as well as later stage solutions to be tried in pilots. So I think almost everything you discussed is still in the marathon phase. So therefore, what would you recommend in terms of CCAM but TRL 7.8?
Thierry, you go first.
I don't know. So in terms of data sharing platform or what? Okay. So the thing is, we have in MobiDataLab at least, we have a technological readiness level which is lower than 7 or 8, because so far there are two approaches actually. You have and this is something that we described in the market study and actors' needs. Everything is on the MobiDataLab website. I strongly invite you to have a look at these deliverables, which are quite interesting. There are actually two approaches. The first one is a data sharing platform per se that you can find in the market, but they are always dedicated to one specific type of data. For instance, if we have in-vehicle data or connected data, or you will have logistics data platform for sharing, or you will have public transport, and everything is in silo, because the volume of data is immense. And there is no actor in the market which is able today to provide a solution which is encompassing all the data available. The other approach is the one we have chosen, is to go to the living lab approach, which is going local and trying to be holistic. So then we could just adapt to a specific local context and then try to cover all the types of actors, all the types of data formats that we have. And then the counterpart is that we are starting with a technological readiness level which is lower than this one, but the idea is to converge in the end. And we propose recommendations to be able to, after the project, that will be some other projects which, based on these recommendations, we'll be able to combine the two approaches in order to have a real efficient data sharing platform which is for several types of data, several formats, several use cases, and which will be efficient.
Would this be something like a federated solution?
Exactly. We are working on this federation of cloud services. Exactly. That's the approach.
To me, TRL classification is a bit misleading, because when you say you are on a 7, 8 or even higher, you could say, okay, I'm kind of on the market. But the market is a business question, financial question, so you need to associate to the TRL also the economical costs or the business outlook with a specific TRL. I tend to say that the autonomous driving industry in general cannot be higher than on a TRL 3 maybe today, because even the sensor set definition, and we are on a research conference here, even the sensor set definition can change. The question regarding redundancy, the question regarding what is the optimum configuration for a specific use case. I understand that for evaluation of projects you need to have a TRL setup, and I understand that after 8 or 10 years you could say, okay, but you must have advanced. But the going to market needs to be put into the TRL discussion, and that hasn't taken place because you don't just want to have safe technology on the one hand, which you could classify being TRL 8. You also would like to scale, because we do have climate objectives, we do have safety targets to achieve, climate targets to achieve, safety targets to achieve. And by just having the TRL for talking about this is simply not enough.
Sorry, you need a microphone to be heard by the full audience.
Thanks. The reason I ask this is because in EUSPA calls, as well as in some mission calls, they specifically refer to CCAM all over the place, and also say solutions should be TRL 7, 8 level. So I guess Commission has something in mind here. Maybe then the questions to the Commission here.
Well, that's a challenge to you, Andrea, to what extent you want to pick that up.
Yes, very rapidly. I think the first thing that we've got to understand when we're speaking about CCAM is that you can't say it's a TRL 3 or TRL 8 for the entire automation of transport. It's not going to be a big bang. It's not that from one day to the next we'll have every single vehicle on the roads will be automated while until the day before they will be driven. There are certain dimensions of automation that are already on the market. If we look at the possibility to go on a highway with a car that drives by itself in a very specific use case, this is already a reality that is even supported by regulation both at European and national level. I'm thinking of Germany. So this is already a reality. Is it level 5 automation? No, level 5 automation will be probably in 50 years. But it's already a certain form of automation that is a reality, so it's already on the market. Other dimensions, like maybe valet parking, so again, very specific use cases, might be on the market very, very quickly. And there are other, when we're speaking about specific sensor suites or specific capacities of functionalities that can be enabled, we might be very close to high levels of TRL. When we're speaking about other functionalities, we know that still today the level of maturity of technology might be still very, very, very low in terms of still a lot of work to be done. So I think it's impossible to give one categorization in terms of TRL. Where are we today in automation? It's a marathon. It's a progressive introduction in service of different functionalities that will be made available. Step by step, use case by use case, enlarging always more the use cases.
Thank you. As you seem to have not too many questions left, I have a question to you. Sorry, you do have, then you go first. I was about to challenge you as an audience, but you were just saving the rest of them. Thank you.
Well, I'm Paolo Sospiro, University of Florence. A lot of questions, but I try to, let's say, to summarize just one question about this topic. It seems I would like to ask all of you whether, do you get any difficulty, to find, the right skills and the right technology and the right companies in order to run your project in Europe and the European Union? Because as far as I understood, such as Dimitri told us before, we are not in the United States. So do we have, these kind of skills, or skills and technology, and as well as, those companies that can upscale and then, let's say, help us, to achieve this kind of, let's say, of level 5 or whatever, and in which time, let's say, we can achieve this kind of objectives.
Thank you for that question. Sven, yes, you go first.
First of all, forget level 5. That's like believing in unicorns.
They don't exist?
Sorry. But Santa Claus does, so.
Okay, good, thanks.
My personal view on this is that the skills exist in Europe, definitely, but to figure them out where they are, that is a real challenge. If you look at certain research consortia working together, aside from some specific private partners like car OEMs in general, it's very difficult. You have consortia with 20, 30, 60, 70, 80 and plus partners, hoping that we all have the right skills amassed with us. But there is still this lack of exchange between what happens at the European level. Even days like these are important to figure out what are the other projects that live there. We need this. We need to know who are the partners there. I need a book to figure out who is here, who is who, etc. That is necessary to understand what skills there exist and where you can find them. They are there, but for me the difficulty is really finding them. That is a tricky thing.
Thank you. I think, Dimitri, you also bumped into issues on skills in your project, right?
Yeah, well, we do have the skills in Europe, maybe more than United States. However, we don't have the money. We don't have the risk-taking to invest to, let's say, risky technologies. So How are we going to pay the people? I don't know. That's where the European Commission is helping. But if I consider that Google is putting 2 billion per year for autonomous driving, how much do we put in Europe? Yeah, we can forget it. And still they haven't made it. So L5 is far away. L4 can be there, but somebody has to finance. Somebody has to take the risk. We're talking about sensors. Yes, they're expensive today. But that's how it was the GPS sensor. That's how it was the Wi-Fi sensor. Today you find a GPS in a watch. It's just a few centimes to add it. So once we have mass production, the sensors will go down, and your system will have 55 sensors. Who cares? Just a few centimes each. We just put them, software to control them, but we need the money. We need risk-taking, and we don't have that in Europe. That's why we don't have Amazon. That's why we don't have any of the big American companies. So the people, as you have seen, many of the people they live in Europe to go to the United States. The Chinese is the government that is paying everything. In Europe, no, we're stuck. Oh.
Well, I think the topic is gaining more and more attention. That's maybe also why you raised the question. I don't think there is a final answer to it. If anyone has it, then I'd be curious. But I think we are creating more and more momentum and questions that we are willing to address, reaching out also to other sectors in our need to answer it. I hope you're going to answer more or less in line with that, because you have switched on the microphone, Arvid.
Oh, Dimitri didn't switch off, but I can say something that we have 300 employees, and it is really difficult to find the right ones for perception topics, safety topics, and so on. It is not an easy task, but we managed to find those profiles, and I am, as a convinced European, sure we have the very same, if not what Dimitri also said, higher capabilities in achieving large societal goals with all the competence and all the centuries of innovation and everything, what is bounding us together. But what we see, and I speak here as a German on that end, we are 30 years after a wall came down, and still we have turbulences, west, east, discussions and all this. So there are political topics which are sometimes hindering us in moving as fast as we could. So we need to bring down all those political topics to really focus on that. Innovation is key on developing the skill set, bringing forward the universities, and that is where the highest effort needs to be put into for the next generation.
If I may also rapidly jump in to say a couple of words in support of the European approach in comparison to the US approach. The US approach is true, it's very risk-taking, but it's bottom-up, driven by the single industries in the end. What we have in Europe is, maybe we're slower for certain things, but what we managed to do it together. We've put in place this partnership now between the public and the private to draw a roadmap on how to do a joint effort towards automation. And this is an enormous strength that actually they envy us also in the US, because we've got this combined approach where when we decide something, we all go in that direction. And when it's ready to be deployed, it will be deployed. And then we don't go back, because it's really something that has been totally consolidated. While in the US, it's more far west approach, if I may, and I'm not saying it in negative terms. I mean, they have the capacity to go quicker in deploying something. But is that really what is going to stay? Maybe not. Maybe every now and again they need to make even some steps back. In Europe we're slower, but we have bigger inertia, probably.
Thank you for that. Really, most welcome. Well, I think we are going to a closure, because the audience has been very patient with us, and I think we shouldn't challenge them too much longer, to be honest. Just stop it. Come to us later on, because I think the time is challenging for most of us. Just wrapping up quickly, I think we have seen some of the struggles and some results that you have presented, also on how to transform data into actionable source of information, which was a quote I liked very much. I have to think about that in my upcoming activities also. So thanks for that. We have a bit touched on joint learning and transfer of knowledge. We could have been digging a bit deeper in it too. We had too many other things to discuss. We discussed also the importance of challenging use cases based on actual questions and needs from, for instance, cities. If we want to make a chain towards true implementation. We talked about some of the actions that are needed to make project results applicable to other cities as well. And we talked also about how projects are part of a bigger picture. And, well, we had a metaphor of the marathon. I have to say, I was always stuck at half a marathon. I never made it beyond that limit. So, but I'm willing to go the extra mile, and I realize it's more than just 1 mile extra. And I think that bigger picture towards on-road implementation, we need to see it like that and make it. And I think we had a nice closure of the session also on the skills needed towards the future step in our joint European approach. So thank you for challenging our speakers, and thank you all for being here and for being so clear. Thank you very much.